This is my Lab 3 Part 1 Constant Velocity Motion Lab. My name is Rebecca Fack. We were asked to observe an object moving at constant velocity in one direction. So what I observed was this smiley face moving at constant velocity in the x direction here. You know it's moving in the negative x direction. That's fine. Just means all our values are going to be negative and then our velocity will be negative. You can see here that we tracked it along in the different frames to get all our data points for where it was moving. And we can say that that's the distance it was actually moving because we calibrated it. And you can see that I knew that this distance was 5 centimeters, and so now we can use that to relate it to the actual distance it was moving. Also, another adjustment I had to make was I started it at the origin so that that's where I started, and then I was able to move it along and just keep it moving along the x-axis as much as possible. Then, after I had this data, which we will use later, the time versus distance, I then used Python to create a virtual simulation. We started it at the 0 vector, and then because I started at the origin, and then had this initial velocity of negative 0.168 in the x direction, and there was no change in velocity in the y or z, so it wasn't moving up and down, and it wasn't moving out or in. So I got the x velocity by using tracker. You can see here that I saw that it moved a total of negative 0.23 meters in 1.37 seconds. And so if you divide the change in position by the change in time, we can get the average velocity as we have here. And then came down here, and you see that in this experience we had made the assumption that F net would equal 0. And so as you can see, that means that the initial velocity and the final velocity will be equal, because this variable here is going to turn out to be 0, because the 0 vector will cancel it all out, delta time, everything. It's just going to be final velocity equals initial velocity. So then, when we run this, you can see the ball, which is the blue, or the smiley, which is the blue object, moves constantly to the left from the origin. As you see on the graph here, time being the x-axis, position being the y-axis, it moves at a constant velocity because the velocity is our slope in this situation, and it's a constant velocity. We then took the data from the Python, and from the tracker, and we were to compare it in Excel. The blue line is our Python, again, constant slope, and the trackers are red. It's not as constant just because it's not completely straight, just because we had a little deviation in the forces that were acting on it. So yes, the Python programming is a fairly good prediction of the motion found on tracker. There's just a little deviation because the friction and the applied forces were not assumed to be equal, could not be assumed to be equal at all times, just because of a little bit deviations, but we made that assumption. What if we used a different point in the origin? So if we were to use a different point in the origin, nothing really changes. It's just where it starts and where it ends changes. The distance traveled doesn't change. The velocity doesn't change. It's just kind of where it starts and where it ends up is what's changing here. So you can see it no longer starts at the origin, and it no longer finishes where it finished before. But the distance traveled is the same. Only thing we had, and the slope is the same. It's just where it starts, where it finishes. That's what's changing. What does it mean? Is it possible to say? I'm going to say that I can say that I know all the forces acting on it. I would assume that as we look at the video, we have the normal force, gravitational force. We have the applied force by the hand and the frictional force, but we don't really know if there's more applied forces, because we can say we don't really know what the applied forces are, but we just know that there is one. And in this case, we couldn't keep track of that the frictional force and the applied force were canceling out, or that were the same, because we weren't recording how much applied force we were applying. We were just kind of using our eye to track to see if it was continually going at constant velocity. So that's my lab 3, part 1. Thank you.